Everybody, I want to do a little law science practice. Now this was tested on this last week, but just in case you're still feeling squidgy about it, here's another practice problem, and it's kind of trying to work through the thinking. So let's say this is 46 degrees, this is 42 degrees, and this is 35 degrees. So the key to the law of sines is really the fact that I need to connect up these pairs, right? So I have an angle and a side. I have another angle and another side. I have another angle and another side. So these Z is across from alpha, and X is across from phi, and S is across from theta. Also, these are angles, and these are sides. So these are the ones that go in the sine, right? So sine theta, sine alpha over Z is a ratio. Sine phi over X is a ratio. Sine theta over S is a ratio. And these are all equal to each other. It doesn't matter if I do the sine on top of the sine on the bottom, that's kind of up to me. So as I'm analyzing this problem, I'm looking at to see where are the pairs that I have available to me and what's a pair that's missing one piece of information, right? Because if I'm given three pieces of information, I could have various configurations, including an option where there's no completed pairs. But in this one, there is a completed pair, which is that sine 46 is across from the 35. So now I'm going to set up the other side, which is sine of theta over 42. So this angle is across from the 42. This is the one that I can work out. So now I can work out what sine theta would need to be equal to make this work. That would be my first algebraic step. My calculator out. Okay. All right, 0.8632. This, of course, is not the angle. This is the sine of the angle. So now I can use the inverse sine of 0.8632 to find out the angle. Now, the reason I asked this problem, in addition to just thinking you might need more practice, is that it's possible 59.7 degrees, rounded to the nearest 10. It's possible that actually there's two solutions to this. Now, you've already come across math problems where there's two solutions, right? Let me just give you a simple one. X squared equals 4. X could be equal to 2, or X could be equal to -2. So I need to think about that. When I'm looking at this type of problem, I need to be aware that it's possible that there's actually two solutions. And of course, when you use inverse operations, you say, well, I'm going to take the square root of both sides. You're kind of forced into one answer. Like if you put this into your calculator is only going to tell you 2. It's not going to tell you -2. Same thing happens here. There's actually multiple places where sine will give us a value of 0.8632. How do I know that? Well, I'm just thinking about the unit circle. Sine values are connected to the y coordinate. This maximum value here is 1. And I'm looking for sine to equal 0.8632. So somewhere like, a little higher up than 3/4 of the way. That happens here, but it also happens here. And of course, I could keep rolling around the circle and getting more and more answers. That's irrelevant for triangles because I can't have an angle in a triangle that's bigger than 360 degrees. But both of these values are in the range of possibility for a triangle because this is 0 degrees down here. This is 180 degrees over here. So this angle and this angle could both be in a triangle. A lot of times this angle is too large. And so it's sort of not a possibility just because of the other angle present. But let's just take a look. Well, first of all, what's the relationship, mathematical relationship between these two things? So if this is, say, 60 degrees, then what's this angle? Well, we know that this is symmetrical, so this would be 60 degrees. Let me redraw this now. It's getting a little bit messy. Okay, so we're over here. We're looking at 2 points. I just made up a degree measurement. It's pretty close to where we are actually, but 60 degrees. So logically, this matching one would be 60 degrees up on this side. But I'm interested in the angle measurement from the reference point of the positive x-axis. So what is this? Well, it's just 180 minus 60. So 120 degrees. So sine of 60 degrees is equal to the sine of 120 degrees. And this is generally true. Sine of theta is equal to sine of 180 minus theta. Not true for cosine, but it's true for sine. So let's take a look. If I find that this is one of my answers, I'm going to call it theta 1, then there's another possibility, theta 2, which is 180 minus theta 1. So in other words, 180 minus 59.7. So that makes the answer, this is rounded, 120.3 degrees. Okay, and I'm just going to check by doing the sine of 120.3 degrees, and it should give me something very similar to my answer here. It gives me 0.8634. So it's a little bit off, but again, I had to round this. So this is giving me an imperfect answer, and this gives me something close to that. So there's actually two answers here, and they both work because if you take 120.3 and you add it to 46, it's still less than 180, which leaves you enough for a third angle. And in fact, this drawing makes the 120.3 look like the more reasonable answer, but there's actually two answers. Let me try to draw the picture. So in the law of sines, sometimes you have a situation where you have this given to you, and you have this piece of information, and you have this side, but this side really, there's two ways of configuring it to be that length. The other way would be to go over here and go 35. Then this angle is theta 1. This angle is theta 2. This is 35 either way, but it makes a big difference to what this angle is going to be. And of course, makes a huge difference to what this side is going to be, because the side could be relatively short or it could be the longest side. So this is an ambiguous case where there's actually two whole different sets of solutions in terms of what theta could be, what phi would be, and what x would be. So those three values would be different for each of the two triangles. And that's called the ambiguous case in the law of sines. Okay, fun on a Sunday.